dive in. Today, we're talking about the very nervous system of the modern factory. You've probably heard these terms thrown around: IoT, EAP, SCADA, but let's be honest, the lines between them can get pretty blurry. So in this explainer, we're going to clear all that up. We'll figure out exactly what each one does and, more importantly, why it's such a big deal for the future of manufacturing.
So here's our game plan. We'll start with the big problem all these systems are trying to solve, that classic communication gap between the factory floor and the front office. Then we'll break down IIoT and EAP, think of them as the data bridge. After that, we'll switch gears and look at SCADA, which is kind of like the factory's cockpit. Then we'll put them head to head, and finally, we'll see how they all come together to build the smart factory of tomorrow.
Okay, so let's start with the root of the issue, the IT/OT disconnect. You see, at the heart of any factory, there's this one fundamental challenge. How do you get the actual physical machinery, what we call operational technology, or OT, to talk smoothly with all the business software, the information technology, or IT? That's the core communication problem right there.
For years and years, factories ran on the old way you see on the left. It was a total mess, a tangled web of custom code. Every single time you needed a machine to talk to a business system, a developer had to write a one-of-a-kind connection. The fatal flaw? It all depended on that one person. If that developer left the company, all that critical knowledge on how to fix or update that fragile system, well, it just walked right out the door with them. The new way, thankfully, replaces that chaos with a standardized bridge. It's like having a universal translator for the whole factory.
And that standardized bridge brings us right to our first modern solution. So Section 2, IIoT and EAP platforms. These are the data bridge, the technology that finally properly connects the worlds of IT and OT.
So what exactly is one of these platforms? Well, at its core, an industrial IoT or an equipment automation platform is basically a software framework that acts as that data bridge we've been talking about. Its main job, really its only job, is to standardize communication. It takes in all the different messy languages spoken by the machines on the factory floor and translates them into one clean, consistent format that the business systems can actually understand and use.
And this is what that looks like in practice. On the left, you've got all these different machine protocols coming in, things like OPC UA, SexGem, Modbus, a real alphabet soup. The platform's job is to translate all of that into a single structured format. Then it sends that clean data over to the IT systems on the right, like your ERP, a cloud database, or some analytics platform. The most important thing to get here is that this is all happening in the background. There's no fancy dashboard or user interface. It's just a silent, super powerful engine making it all possible.
You know, the real win here is focus. When you centralize all that protocol translation, your developers are suddenly free. They don't have to be experts in dozens of obscure machine languages anymore. Instead, they can focus on the business logic, what your company actually needs to do with all that data. This one change makes the entire system so much easier to manage, maintain, and grow. Okay, so we've built our data bridge. Now let's talk about the other major player in this whole thing. Section 3, SCADA, the factory cockpit. So if the IIoT platform is the factory's nervous system, you can think of SCADA as its interactive control panel, and it's designed specifically for people.
There's this quote from our source material that just nails it. SCADA is the eye and dashboard for on-site monitoring. That's its whole purpose in a nutshell: to give human operators a clear, visual, real-time window into what is happening on the factory floor right now. So SCADA actually stands for Supervisory Control and Data Acquisition. It's a software system that provides a human-machine interface, or HMI. You know, it's the screen that lets an actual person see, monitor, and directly control all the industrial processes as they're happening. So how would an operator actually use this? Well, picture an auto assembly line. First, the SCADA system lets you see the entire line, all on one screen. Then you can click on any specific machine or station to drill down and see its live status and data. And here's the most important part: you can interact with it. If you see a problem, you can literally press a button on the screen to pause that part of the process or to clear an alarm, all right there from the interface. Okay, so we've got the data bridge, that's IoT/EAP, and we have the factory cockpit, that's SCADA. Now let's jump into Section 4 and put them side by side. This should make their different roles crystal clear. This table really breaks it all down. Just look at the core function. SCADA is all about real-time human control, while IIoT is for automated data integration. That difference shapes how they handle data. SCADA is visual and in the moment for an operator,
while IIoT is focused on API-driven exchanges for other systems. You can also see this in their application level. Think of these levels like floors in a factory building. Level 1 is the machine, level 4 is the business system. SCADA lives down low, close to the machines, while IIoT sits higher up, bridging that gap to IT. And that makes it obvious who the primary user is, a person for SCADA versus another computer system for an IIoT platform. So if you want the simplest way to remember all this, here it is. SCADA is the factory's cockpit. It's visual, it's immediate, and it's designed for a human to be in control. In contrast, the IIoT platform is the data hub. It's working silently, behind the scenes, just collecting, processing, and routing information where it needs to go. So that brings us to the big practical question. Which one do you actually need? Well, you'd go with SCADA when seeing what's happening and having real-time operator control is absolutely essential. Think about continuous processes, like a chemical plant or a water treatment facility. On the other hand, you choose an IIoT or EAP platform when your main goal is just getting data from point A to point B. This is super common in what's called discrete manufacturing. Think semiconductors or circuit boards. And it's a total must-have if you plan on connecting to the cloud for AI and analytics. But here's the thing. This isn't always an either-or choice. In our last section, we're going to see how the most advanced factories are actually using both. This is the smart factory future, where these two tools are way better together. Yeah, the most powerful modern solutions don't pick one over the other, they integrate both. In a setup like this, SCADA acts as the essential front-end interface, right? It's the cockpit for the human operators. But at the same time, the IIoT platform is the back-end data pipeline, gathering information from all the machines and even from the SCADA system itself to feed everything into those higher-level business and analytics systems. So why go through all the trouble of building this kind of robust data system? This chart really puts it all into perspective. Sure, real-time monitoring is important, but it's only about 10% of the reason. The ultimate goal, the whole point of collecting all this data, is to fuel the future of manufacturing. We're talking about enabling powerful AI models for things like predictive maintenance, optimizing processes, and advanced analytics. That, right there, is the true endgame of a smart factory. Which really leaves us with this final question to think about. Every single factory on the planet is generating a massive flood of valuable data every single second. So the real question is, what's your strategy for it? Are you building a data bridge to move it, a cockpit to control it in real time, or are you building a truly intelligent system that uses the power of both?